morning, afternoon, everyone. Thank you for joining me. Hello and welcome to another Symetrix webinar. I'm your host, Stu Paterson, a technical sales engineer. And today we're going to be discussing gain staging and how it relates to designing a system around our products. This discussion will be focused entirely on how Composer handles gain structure and how we calibrate our input levels based on the source material, input, middle, and output processing, and finally the outputs, whether that output is an analog output or a Dante TX bus or transmit bus. But before we begin, we need to make a few assumptions here in order to remain focused on Composer only. Assumption number one. We will treat every audio source, like a mic or BMG, or audio destination, such as amps, in the signal chain outside of Composer as optimized to send or receive line level. We're just going to focus on Composer in the signal chain. And our DSPs, of course. But it's assuming the source and the destination, whatever that source is and whatever the destination is has already been optimized or will be optimized. Second assumption, that you're already familiar with basic gain staging techniques within an audio system, though are unclear how Symetrix manages gain within our DSPs. So because this isn't an entire discussion on just broad gain staging. It's how it relates to gain staging within Composer. So let's take a look at the beginning of the signal chain. Let's say our DSPs. Now, I just want to go over a few things first, simply because once we're in Composer, it'll start making sense, but let's just explain how we deal with it. So what were we looking at? One of the last, when deploying a system, a Symetrix audio system, one of the last things you do after pushing your programming through a DSP is setting audio levels. But you need to know, and it's critical to knowing, we need to understand how gain is passed, handled, etc. in our programming. First and foremost, what are our gain levels? What are our trims? What do they mean? What do they do to the signal? How do we set the initial gain of the inputs? How do we set the final gains of the outputs? And how do we read the meters, more importantly? So let's kind of begin. So on the screen now, we have three of our products. Different product ranges have different analog input controls for gain control. On the left, we have our Solus. In the middle, we have the Radius NX, and on the right, we have the Prism. And you'll notice two things. One, they have identical faders on the left, but different middle sections that are called level or gain. So the faders are trim, and that trim is digital, which is important to know. So let's go ahead and take a look at that. On the left, we have our fader, but we also have level, mic, and line. So all it's really telling you is this, that we have an input level that's expecting a +4 dBu line level signal if it's set to line, or if the signal is expected to be a microphone, it adds 40 dB of gain with that in mind. So because it's expecting a line level, but you only get the two choices. It's either expecting line level to be exactly +4 dBu, or it's giving you a 40 dB boost for mics. Now, contrasted with that, and let me go backwards a little bit. This is analog. So this is analog gain here. So the level, gain, whichever one we say here, is analog. So moving forward, now with our Radius NX, you can see that we have an actual knob, a turnable knob, in order to set the input source gain to an adequate level to where we're getting our dBu reference or our +4 dBu reference. And you can see down below, it'll actually tell you what it's expecting. At this point, with the dial set to 0, it's expecting +4 dBu reference. However, if it's mic level, you need to increase it depending, or if it's even a negative 10 dBV, like a consumer grade device that is passing a negative 10. You would need to set it there, and that's how you would do that reference. Again, in contrast, now we have our Prism, which gives you a little bit more control than, say, the Solus, which only gave you 2 choices, line and mic. This one, we're setting it to our expected signal level. So if we're expecting +4 dBu or line level from an object, from a professional console, we can set it there. If it's a a consumer grade, we can set it to negative 10 dBV, or if it's various mics with various gain requirements, we can set it from negative 20, negative 40, or negative 50. Again, these are all analog. Now, I mentioned that this fader, so that's the initial gain stage, and we'll get to how it relates to metering later. So now, as I've stated earlier, all 3 have digital trim. Now, our digital trims, or our gain in general, once it's past the analog to digital converters, which is what's happening with the gain, the initial gain and level, once it gets converted to digital, this is where you can increase or decrease the volume or the level through the remainder of the programming. And we use floating point calculations as opposed to fixed point, so the resolution is much better, much greater. That leads us to metering. Well, in order to set your levels, you use the meters, as we all do. If you're a sound guy or sound person, whatever, you set the levels based on the meterings. But you have to know what kind of meter we're talking about, and that's a subcategory of this discussion. All metering within our products is peak. All metering in Composer is peak, not RMS, which means in order to get a good approximate RMS level, you need to get the meter a little hotter than you normally would think it would be. So moving on, normally, so I mentioned before that we talked about +4 dBu, but what does that mean? You can clearly see these meters go from the top is 0 and the bottom is -72. That's because the meter is dBFS, which is dB full scale, so it's digital. But we have our approximate +4 dBu level, which is going to be -20 dBFS, which is very common in most products, most other companies. Their +4 dBu reference or digital reference for dBFS is going to be right around -20. Some are 18, some are -22. You get the idea. You know what I'm talking about. So we want our reference, we want our inputs to at least get to that level right there. Not at least, but at maximum, on average, hitting -20 dBFS for maximum gain structure and signal transfer throughout the rest of the program chain. If it's too low, then we're turning things up and we don't have a lot of gain control. If it's too high, we run the risk of going above 0. Well, there is no above 0. 0 is the ceiling on dBFS. That's it. You run out of 0s and 1s, which means it starts muting certain signals. So we have to balance those two together in order to get adequate gain structure throughout the remainder of Composer. All right. Now let's talk about the outputs. So outputs are the same thing. But you'll notice that our fader for the outputs, it's a little different. It doesn't start in the middle at 0. It gives us +12 to -72. So this is an analog output. And again, if we're doing things correctly, our output is going to coincide with plus 4 dBu, or at least close to it, which is going to be approximately negative 20 dBFS, as seen here. So let's go ahead and jump on to Composer. So 1 second. All right, so I have on screen, we're in Composer, and we're going to take a look at the programming first and foremost. So this is just a typical programming. I have random noise generation supplied to by this Solus, and I've calibrated it to several levels. I've calibrated to at like a plus 4 dBu. I calibrated to negative, I believe, if our memory serves, negative 16. And then we have a noise generator and a tone generator, both set to plus 4 dBu reference. So, and it's just it's a very, very easy program. It's very, very easy programming. So we just start with our analog inputs, and most of the meat is going to be in our dynamic section or the super module. So we need to ensure that we have adequate gain throughout. And then we have our VCA that's controlling the overall volumes, and then our trims for customer use, because we don't want to give them too much control in the front of the programming. We want to give them their control where we know it's not going to mess things up. And of course, our analog outputs. Very basic. But let's talk about the inputs. So right now, let me go ahead and call this up. Let's set that to plus 4 dBu. So this is just a random noise, or not even really noise, random signal generator that I've set. And every so often, you'll notice that it will, on the peak meter on the left here, it will nearly spike at 0 dBFS. It doesn't actually hit 0 because I put it to within an inch of its life here. But I just want to show you the difference. So this meter on the left here, peak, is corresponding with the input meter on the actual analog input module, as you see. So I've set it that way because if we go over to RMS, RMS is a little hot, and you can see that it's almost hitting at 0 on the peak meter, but RMS, we're right around negative 12. Ideally for RMS, we want to be around negative 18, negative 20. So in this case, since we've already set the analog gain, like over here we have our analog gain, I have it set to 0 for a plus 4 dBu reference because I know what the reference is. I'm going to adjust the digital trim to bring that down, or to bring the RMS value down to right around negative 18, negative 20 on average. Of course, there's going to be a few peaks here and there on the RMS side, but you'll notice the peak meter, of course, is still reading higher than RMS. So even with the RMS, on average, we're right around negative 20 dBFS, whereas the peak meter, we're hitting right around every now and then negative 12, if not negative 10, almost a negative 6, which is okay. Generally speaking, when setting the digital levels, I go for around negative 12 anyway for a peak, just to ensure that my negative 20 dBFS is adequately set at that level. So now you can see the disparity somewhat between the two levels. But if I were to think of, as most of us do, if we think in the realm of, okay, I need to keep it at negative 20, and I set, let's go down here to negative 18. What are we getting? Let's go negative 20, actually, because I already have it set for negative, for 0 dBFS. So now we're at negative 20, so it's at the typical level you would want to see normally a meter. But you'll notice, because it's peak, it gives us the level that we're used to seeing, hitting roughly right around negative 20 dBFS. But you'll notice on the RMS meter that we're barely getting over negative 30 in some cases. So our volume throughout is slightly less. So you got to keep that in mind when setting your levels. So every module or every meter within Composer is peak. Now we do have an RMS meter, but that's in the controller category. So it's actually this module right here. Let me go ahead and close this. So it's this audio level detector is what I'm using, set to RMS. That's one of two modules that are capable of reading RMS, and they're both in the, let's go here, in the control module section, I believe accessories, there we go, yeah. So in the control accessories, audio level peak detector, audio level and peak, I should say, detectors. And they can each be set to RMS. That's it. It's the only ones in Composer. Everything else is peak. So bear that in mind when setting levels. You could do what I've done is add this to your signal chain so you can actually see what RMS values are compared to peak. That's always a good thing. If you're that pedantic about sound, and being an old sound guy, I am. So it gives you adequate representation of how much volume you get later on down the line. We've all had issues with certain installs where we just don't have enough volume at the end. It's like, why is everything so low? I have to turn my amplifiers up nearly all the way. Well, some of the problem can be it's just not set correctly at the beginning. Well, that's not to say for the middle of it, of course. So let's talk about the middle section or the middle processing. Once it's in the digital realm, what can we do with that volume? As I mentioned previously, we utilize floating point calculations, which means, technically speaking, we're using all the bits. We're allocating everything to the bits, which means effectively that you can turn the volume up as high within the middle section. Of course, I'm only referring to in the digital realm. You can put in a 120 dB boost and then immediately a 120 dB cut, and the audio will be perfect. There will be no distortion because it's floating point. It doesn't destroy it. It just it realizes or takes that calculation and redoes it back down to that level. That doesn't mean that there's no danger of going above zero. There is, but you can bring it back digitally to an adequate level if you want to, or if you're stuck in that position. But the best position to be in is to set everything just zero throughout and then adjust from there. So you'll notice with my input, I have several filters, several dynamics, as well as we have our compressor limiter. Now I have my compressor limiter set to where anything above -6 dBFS, it's going to engage and clamp down on that output signal. So that's one of the reasons why I wasn't as afraid. Now, I'm going to make a point here by stating that all of this is based off a controlled input. I know exactly what is being inputted into that signal chain. I 100% know exactly. Now, if it were a microphone, that's harder, of course, because you don't know who's going to be on that microphone. It could be somebody who eats the mic. So we have to play around with the volumes. But this is just more of a perfect presentation. Our representation, I should say. All right. So now we've gotten that. And it's always a good idea, as you see here, everything's zero. We want to start off with zero until the end. So here we are on the analog outputs, and here's my outs. And let's see, I think I set it to, 1 second. Did I turn it down? Oh, I did. I turned it down to -18. That's why. All right. But this is the analog realm. So if we need to turn this up, we wouldn't want to do that here because this is now analog. And if we do that, we can start to distort. So we can bring that volume up. If we had this mixer right here, trim, let's bring that up plus 18. All right, now our output level is right around where we need it, maybe a little bit hotter. So let's bring that down. -6. All right. So we're right around that output. But again, this is peak. So if this is peak, what is that going to be with RMS? It's going to be roughly 12 dB depending on the signal choice. So bear that in mind when setting your output levels. We need to have adequate output levels, and so you absolutely do not want to go into the red, hitting 0, but we want to get close enough to where we have adequate headroom, but we also have adequate output volume, so we can turn down our amplifiers, so we have that control. Because once you turn your amplifiers all the way, that's it. That's all you get. You don't have that control of your system. Oh, I failed to mention that, of course, as we stated in the beginning in my PowerPoint, that our +4 dBu value or reference is going to be right around -20. So remember that as well. So +4 dBu is right around -4 dBFS. Or I'm sorry, -20 dBFS. I misspoke. All right. Well, if that's the case, I want to thank you all for joining me. I appreciate that. Let's go this. So if you have any other questions, guys, you feel free to contact us for more info. Like you can go to our website at www.symetrix.co, or you can give us a call at 425-778-7728 extension 5, and we'll be happy to answer your questions. All of our guys here are sound guys. I'm a sound guy. We have actual working sound guys here with Chris. So we're all audio engineers. So if you have more gain staging questions, please don't hesitate to contact us. We love talking shop. We're sound nerds. And with that, I thank you all and have a great rest of the day.